Alright, so in this video, we're going to be moving on to slightly more complicated examples, and since we've built up some intuition as to how to solve these so far, we're going to be able to skip a few steps along the way. So I'm going to be appealing to a little bit more intuition as we go about solving this. The expression we're looking at is the quotient of cube root of x times y times the cube root of x all over the cube root of n squared. So how does this simplify? As before, we want to use the quotient and product rules for simplifying rational expressions. The first thing I notice here is that I'm working with a cube root. I want powers of 3, or rather I want powers of 3 of whatever the heck I am working with here. In this case, x's, y's, and n's, in order to cancel out that cube root. So in this case, I notice I have an x and an x squared here. So hopefully I can combine those so I get an x cubed and can cancel the radical. Here I only have one y in the expression and I have two n's. So I'm probably not going to be able to cancel those things out using the radical. But the first thing I notice, aside from the radical of 3, is that, well, I have the same power on both these radicals. Therefore, I can combine these two guys under the same roof, because the goal was to get this x and x squared together. So let's do that. This gives us third root of x times x squared, because I'm just rearranging the stuff being multiplied, all over the cube root of n squared. Okay, so now I have my three x's. Continuing along this train of thought, this gives me the cube root of x cubed times y all over the cube root of n squared. Okay, this cube root of n squared is not going to simplify. We're stuck with it. We are completely screwed in that regard. So in this, I can use the product rule to expand this, so I get cube root of x cubed times cube root of y all over the cube root of n squared. Okay, so I'm breaking things up so that my life becomes a little bit easier, and so I can cancel out this x cubed and this cube root. So continuing this way, this gives us x, y. Why not absolute values? Well, because I have a cube root and a cube. So whether or not x is positive or negative, we don't actually lose the negative. So we don't have to put absolute value bars around this x. So I'm left with cube root of y all over cube root of n squared. Okay? So are we done at this point? Some would say yes, some would say no. I say no. I think we can do a little bit more. So basically, by fraction rules, I can write this as x times the quantity cube root of y over the cube root of n squared. Just basic fraction rules here. So it's just multiplying across the top. You'll see that you get the exact same thing here. Okay? And then for a final step, I have the same power on these radicals. So therefore, I can combine everything inside the radicals under one roof. So I get x times one giant radical of y over n squared. Remember, I couldn't break down that n squared, couldn't break down the y, so I'm left with basically this. So at this point, I have x times the cube root of y over n squared. And that is completely simplified. So we are done with that example. And if you found this example helpful, please like and subscribe.